So let's get started with this. Section 1.1 is basically just a review of arithmetic. You know, what are the natural numbers? What are the integers? How do you add, subtract, multiply, and divide fractions? That sort of thing, in order of operations, which will be really important. So this will be all very familiar, so we're not going to spend forever on it. I'll hit the highlights in the lecture, and then I'll expect you to kind of just read through to refresh your memory on some of these topics. All right, so let's jump down. All right, so we know the natural numbers are basically the set of counting numbers, 1, 2, 3, 4, so on and so forth. If you throw 0 in, you get the set of whole numbers, and if you throw the negatives of the natural numbers in as well, you get the set of integers. All right, and so how do you work with integers? Well, here are some basic rules. We know if you add 2 positive integers, you get a positive integer. If you add 2 negative integers, you get a negative integer. If you have an integer that is negative and one that's positive, the sum will depend on which of those two is further from the origin, and whichever one is further, you affix its sign to the end result. All right. And if you multiply, you know that if you multiply 2 negative integers, you get a positive integer back. In fact, you can generalize that. If you have a product of an even number of negative integers, you get a positive integer back. If you have a product of an odd number of negatives, you get a negative integer back. And so just try to refresh your memory how to do this and compute those two expressions right there and see what you get. All right. So when I tell you to do that sort of thing in these videos, the idea will be to pause the video. I forgot to tell you at that point, but anytime you're listening to these videos and there's a question that pops up or a your turn that we'll encounter, at that point in the video, pause, attempt the problem, and then restart it, because I won't pause it but maybe a couple seconds and then go on. All right, so for these two, the first one, 4 minus a negative 5 really means 4 plus 5, and then we know that's 9. And for the second one, notice you're multiplying 3 negative integers, so you're going to get a negative integer back. And to get the product, you just multiply the numbers without sign consideration whatsoever to get 24, and then you affix a negative to that to get negative 24. All right, next up, what is a rational number? Rational number is basically a fancy name for a fraction, which you're all familiar with. And the big no-no with fractions is you cannot divide by 0. Right, so we all know that. The top of a fraction is a numerator, the bottom's the denominator. And by simplified, we mean that there's no shared factor in top and bottom. So below, what I did was I gathered the basic operations for how you add, subtract, multiply, and divide fractions. For adding and subtracting fractions, there are 2 cases. If you have the same denominator, you simply add or subtract the tops, keeping the bottom the same. You don't add or subtract the bottoms, just keep it the same. And then once you've done that, you simplify, you cancel any like factors in the top and bottom. In contrast to that, if the bottoms are different, you have to first find what's called a least common denominator, and that's where prime factorization comes in. You can practice a little bit of that. But once you do this, once you convert each fraction to an equivalent one with the same denominator, then you can proceed as you did before and add or subtract the tops, keeping the bottom the same. This one here is just really notation. If you multiply a fraction by -1, you can multiply the entire fraction by that -1, or you could put the negative in the top or in the bottom, but you daren't do it to both. You just choose one place to put it and leave it there. All right, but these are all equivalent ways of writing that. Next up, we know that if you multiply 2 fractions, you simply multiply across, right? And so ideally, you don't do that, because if you just multiply across and top and bottom first without canceling like factors, you're going to get a huge mess in the top and bottom that you have to eventually simplify, which can be a pain. So what you want to do is cancel out like factors in the top and bottom before you multiply through. And once all that's said and done, then go ahead and multiply out the top and bottoms. For quotient, the only difference here is that to divide 2 fractions, you convert that to a product by flipping the one over that's after the division sign. Right, so notice here, this quotient is equivalent to this product, and we already know how to multiply from the previous step. Sometimes you'll also see a quotient written in what's called complex fraction form, literally one fraction over another. It looks worse, but it really simply just is a different way of writing that, right? So just, if that's confusing to you when you encounter it, just write it like this and proceed. All right, so go ahead and try these problems, a subtraction, product, and division problem, and see what you get. All right, so now that you've attempted these, notice here you do not have a common denominator. The least common denominator would be 10, right? Because 5 goes into 10 twice. 10 is itself 10. People will ask, why did you just multiply and get the common denominator? And you could. You will get a common denominator if you just multiply those together. But the thing is, it's not the least common denominator. And so inevitably, you're going to have to simplify a lot more once you've subtracted. Right? So the idea is to try to find the least one possible. And that's what we do here. Right? We multiply the first one, top and bottom, by 2, right, to get a fraction that has a denominator of 10. That first fraction is equivalent to 6/10. So if you subtract 6/10 minus 7/10, you just subtract the tops, keep the bottom the same. That gives you -1/10, which, remember, we can write that as just pulling that negative out in front. For the product, notice here you do not want to multiply across because the bottom is going to be a number that's fairly large, right? And so what we could do instead is notice that the 5 goes into the 25 5 times. So you can kill off a 5 in top and bottom there. And also 6 goes into both 12 and 18. So you can get rid of a 6 in both of those. And so that's what we do. Notice here I literally wrote it out. I wrote 18 as 6 times 3, 12 as 6 times 2, 25 as 5 times 5. And then I just crossed off common factors in top and bottom. Once you've done that, now multiply across top and bottom. Well, we only have a 2 in the top, so it stays the same. 3 times 5 is 15, and so it's much better. This is a simplified result and will always be if you cancel all like factors in top and bottom first. So you don't have to worry about simplifying the end result if you do that. And lastly, here for the quotient, notice here I just have to convert this first to a product. And so we're going to rewrite this as 4 times 3/2. And now it's just a simple product. I don't want to multiply across. Here I'm going to cancel that 2 into that 4. That's what I'm indicating here. And then multiply across to get 2 times 3, which is 6. All right, so if fractions have caused you a lot of heartburn in the past, look at some of the extra videos that I posted just to kind of get some more practice. But that's the cut and dry of fractions. All right, so here's some no-nos. These are inevitably things that people do in a pinch, right? So you get nervous on an exam and out come these sort of ways of simplifying that are incorrect, but they seem correct in the moment, right? So these are things to keep aware of. First thing, if you add 2 fractions, you do not add them by adding tops and adding bottoms, right? We multiply like that, but we do not add like that. And so here is a typical, on this column, I'll give you an example to show that it's not true. Right? Over here, you cannot split up a sum in the bottom in this way, right? So if I have a over b plus c, I cannot write that as a sum of 2 simpler fractions, right? You have to keep that sum where it is. And then even kind of similar to that is if I have the same term in top and bottom, but I'm adding in the bottom, not multiplying, you cannot cancel those terms, right? Those are not factors. Remember, a factor is a number that when multiplied by another gives you a given quantity. Here, I'm adding the a and the b, I'm not multiplying them. And so I cannot cancel those common a's. All right. Some of your rational numbers that we'll bump into, well, you're all familiar with radicals, I'm certain. Maybe not like them, but you certainly have seen them before. You've dealt with pi if you ever dealt with circles, areas, and circumferences. And e you may or may not have bumped into. We'll talk about that later on in the course in chapter 4. But suffice it to say that e is approximately 2.71828, ... It's irrational. It never stops, it never repeats. All right, so the next is just a list of properties that you're familiar with way back from grade school, right? And so I'll talk very quickly about them. and they apply for all real numbers. Doesn't matter what numbers you give me. All right, and so first, commutative property. You can switch the order in which you add or multiply numbers. Doesn't matter what order you do it in, you get the same product or sum back. For associative property, you can group terms of a sum or of a product in different ways and you'll get the same thing back. So if you want to add the first two numbers, or if you want to add the last two numbers, that's fine. Go ahead and do that. You'll get the same thing back. Same with products. For the distributive property, you're multiplying a number times a sum, right? So what you have to do there is literally multiply every term inside the brackets, if they're being added, by that number on the outside. So I distribute literally the A to the B, get A times B, keep that sign the same, and multiply the A times the C. Had there been 3 or 4 terms in here, I would do exactly the same thing to each of those 3 or 4 terms. You've all heard the term FOIL, right? This occurred when you were factoring and multiplying binomials in your algebra course in high school. All FOIL really is an extension of the distributive property, right? And so I take this A here, I multiply it by everything in that bracket, and then I add to it, take the B and multiply by everything inside that bracket. And lo and behold, I get a sum of 4 terms. We'll talk more about that later on when we deal with polynomials, but I just wanted to list it here as a property because it comes up fairly often. The zero factor property. So this is a big one when solving equations, right? The idea for often is to rewrite the expression on one side of a equation as a product and the other side as 0. If you can manage to do that, keep in mind the only way a product of 2 real numbers is 0 is if one or the other number is 0, or both technically, but at least one of those numbers has to be 0 in order to get a product that's 0. And that's what this is saying, right? So when we solve equations, if both the A and the B involve a variable, this will say, that nasty product is 0 if each of the two, or if one of the 2 simpler expressions is itself 0. So it gives us a way of solving a horrible equation in terms of easier ones, right? And we'll see that often. Okay. Next, you've probably have heard of order of operations, and there's a whole bunch of acronyms and mnemonic devices that go along with it, with PEMDAS or whatever people call it. Punch My Dear Aunt Sally is another one, when I actually learned this 50,000 years ago. But basically what it is a way, if I gave you an arithmetic expression that had sum, difference, products, quotients, exponents, and parentheses in it, where on earth do you start is a natural question. And we can't all just do what we want. We have to have a set order that everyone agrees upon so that we are all getting the same answer. Otherwise, we're going to all solve things different ways, and there won't be a unique answer to anything, which makes all of this utterly useless, right? So the agreed upon convention is that you first start off by simplifying expressions that are contained within parentheses, right? So you first identify your parentheses, if you have any, and for each of those, you then simplify the expression within according to the following 3 steps, right? First thing, you want to simplify exponents. Right, so if you have any exponent like 3 to the 2nd power or 4 to the -3rd power, you want to simplify those first. Once you've done that, you want to perform all multiplication and division as it occurs from left to right. All right, so you don't do any addition or subtraction at all at this stage. You're only performing multiplications and divisions as they occur from left to right. That could take several steps to finish it off. And then 4th step, once you've done all that, the only thing that's going to remain is addition and subtraction. You perform those as they occur, again, from left to right. Don't group them differently, especially if you have the subtractions in there. Subtraction is not associative. You get different answers if you group them different ways. So just go from left to right, one at a time to compute them. All right, so try that, for example. Here's an expression that you want to attack. Try to simplify that and see what you get using the order of operations. All right, so now that you've tried it, notice that we have a set of brackets, right? So you want to hone in only on what's in those square brackets first. That's what we do here. But then within those brackets, we have a set of parentheses, namely the 2 minus the -1. And so I'm going to start my work there and use the property of the integers that tells us that you can rewrite that as 2 plus 1, and we know that's 3. And so this first step here was to rewrite that expression as -2 times -3 times 3. All right, now, well, we'll finish off what's in those brackets. It's just a simple product. That product is -9. Remember, if you multiply an odd number of negative integers, you get a negative back. So we got the -9. And now the final step, that's a product. And so if you multiply -2 times -9, you get positive 18. All right. All right. With here, I'll let you read this example. It's just the exact same thing, but now you deal with fractions. And so you really need to get a common denominator to be able to simplify it. So that's the only additional complication is this dealing with the denominators. But I'll let you read that on your own. All right. Let's actually try the your turn together. So, try it on your own, and then we'll talk about it. But remember, you want to rewrite this whole complex fraction as a division, like the other using the horizontal notation, and then simplify from there. See what you get. All right. So the first step here is, notice I actually went a different way with it, but you could technically rewrite this as the top in parentheses, division sign, parentheses, the bottom. But if you do that, then within each one, you want to get a common denominator. So for the top and the bottom separately, you actually get the same denominator of 6, right? And so I'm going to rewrite each of those as a fraction over 6. Notice here you cannot cancel the 3/6 and you cannot cancel the 2/6 because they're not like factors, they're terms, right? You're not multiplying here, you're adding and subtracting. And so you daren't actually cancel those out. Nice thing is, if you wrote that in that horizontal notation I was talking about, you wouldn't be tempted to do that because it doesn't seem like you have this one thing over the other, right? And so we don't have to even worry about that in that case. But nonetheless, you simplify the top, you simplify the bottom separately, you get 1/6 in the top, 5/6 in the bottom. And now I write it in horizontal form, which you would already have it this way if you did that. To compute a quotient, you're going to change this to a product. So I have 1/6 times 6/5, killed off the sixths, and you get 1/5 as your answer. Okay. So those can be a little tricky. There's a couple on the homework that you should attack just to be sure that you're comfortable with the notation and with fractions. But by and large, just keep in mind those basic properties and you can't go wrong. All right. Try this example before you go on. I just need you to fill in the blanks using the order of operations at each stage. Fill in the blanks to complete the simplification. See what you get. All right. So if you apply the order of operations, what happens in the parentheses here, you need to subtract -4, -4. Well, we know that we get -8 if you do that, right? So the first step here is that the inside is -8. Now, remember, the next thing you do with order of operations is you apply the exponents. And so I'm going to square the -8. Remember, to square -8 means you multiply -8 times -8, right? And so if I do that, I get 64. And then multiply -2 times 64 to get your -128. Okay. All right, and then I'll let you do the your turn on your own. Basically, it's the same process as that. It'll be some good exercise or good practice for you, right? So you can do that and then check yourself afterwards. Okay, and that brings us to the homework problems, right? So like I said, I posted a couple more videos just to get kind of work out some of the bugs if you happen to have problems with fractions or word of operations. Check those out and then try to hit the homework problems and see how you do on that. Okay, very good. Bye.